We're now going to take a look at limits, at asymptotes. So how you know it's an asymptote? Everything we've had so far has been 0 over 0. Okay. What we're going to get now is functions where when we plug in whatever the limit number is, we get 0 on the bottom, but not on top. Okay. So if I look at this first one, if I were to plug in -2, I can see that I'm going to have 2 over 0. That tells me that this graph is an asymptote, not a whole, like what we've been doing. Okay. So what we need to do is do a rough sketch of the graph. Okay. So remember, the denominator tells you your vertical asymptote. So I have a vertical asymptote at -2. Okay. And we don't have any x-intercepts. The rest of the stuff you don't really need to worry about. Okay, so when you're finding the limit at an asymptote, it's really just the vertical asymptotes and x-intercepts that make a difference. So now to do this graph, you would start, since it's positive, I would start above the x-axis, go up. Since this is an odd asymptote, because it's to the first degree, I would start away from it. So what you want to do to determine the limit is you want to look at these ends on both sides. One end is going up to positive infinity, the other end is going down to negative infinity. So since these are going different directions, that means the limit does not exist at this asymptote. So at -2, the limit doesn't exist. So anytime you're finding the limit at an asymptote, if that asymptote has an odd degree, it's to the first power, we always know that these ends are going to go different directions, so it'll always be does not exist for an odd asymptote. Okay. So you could even skip the graph on this one. So then for number 2, when I plug in 1, that's going to give me 1 minus 2 plus 1. That'll give me 0. Okay. So this is going to be an asymptote. But what I need to do first is factor this. So this will factor into x minus 1 times x minus 1, which is x minus 1 squared. So I can see I have an asymptote at +1, and it's even. So that means when we have an even asymptote, we know we have the parts of the graph next to each other. So that means both ends are either going to be going down or up. So these are the ones that we have to graph to figure out. Okay. So for limits, when I'm graphing a rational function, I'm just going to do the vertical asymptote, which is at x equals 1, and the x-intercepts. So there's no x-intercepts here. Okay. I'm always going to start on the right. Since this leading coefficient is negative, I'm going to start below the x-axis and go down. Okay. Now since it's an even asymptote, these two parts are going to be next to each other. So I can see both ends at 1 are going down. Okay, so that means the limit is negative infinity. Okay, so for this one, if I plug in -1, I can see I'm going to get -5 on top, and then I would get 1 plus 2 minus 3. That would give me 0 on the bottom. So that means there's an asymptote. So I have to factor this. So that'll be x minus 3, x plus 1. So since we're finding the limit at -1, that means we're looking at this asymptote here. Okay. Since it's odd, we know that the parts of the graph are going to go in different directions at this x equals -1 asymptote. So that means the limit doesn't exist. You don't even have to graph it. Okay. Now, if the graph is going to help you, you would do your 2 vertical asymptotes. So you have 1 at x equals -1, you have 1 at 3, and this time we have an x-intercept at 4. Okay. So my leading coefficient's positive. There's no negative up here, so I would start above the x-axis, go through that x-intercept. Okay, because the x-intercept is to the first power, so we're going to go through it. This is an odd asymptote, so I would start away from it. Then I'd have to turn around. I can't cross the x-axis because there's no x-intercepts. Then Again, this x equals -1, that's also an odd asymptote. So since I ended up, I would start down away from it. So I could see here at -1, they're going in different directions. Now for this next one, if I plug in 2, I can see I'm going to get 0 on the bottom. That's 4 minus 8 plus 4. That would give me 0 on the bottom, not 0 on the top. So that means we have an asymptote. So I'm going to factor this. This will be x minus 2 squared. Okay. So this is an even asymptote. Okay, so that means the two little ends at the asymptote are going to go in the same direction. So these are the ones that we have to graph to figure out whether both ends go up or both ends go down. So my vertical asymptote is going to be at 2. My x-intercept is going to be at 3. Okay, x-intercepts come from the top. My leading coefficient is negative, so I'm going to start below the x-axis. Okay. And then I've got to go through this intercept. Okay, so I'm going to go through it, and then I'm going to go up. Okay, I passed through it. You would only turn back around if that intercept was squared. Okay. Then since this asymptote is even because it's squared, I'm going to start next to it. Okay. And then I can see at x equals -2, both ends are going up, making the limit positive infinity. So if I look here, if I plug in a 2, that'll give me 4 minus 2 minus 6. That's not going to give me 0 on the bottom. So this one I can just plug in the 2. So this will be 2 plus 1 over 2 squared is 4 minus 2 minus 6. So 4 minus 2 is going to be 2 minus 6 is going to be -4 and a 3 on top. Okay. So this one, since we didn't get 0 on the bottom, all we had to do was plug it in. Now this one, if I plug in 3, I'm going to get 9 minus 3 minus 6, so that gives me 0 on the bottom, and it also gives me 0 on top. So since I have 0 over 0, this is one with a hole. So this is one where I would factor the numerator, which can't be factored, factor the denominator, and then you should be able to cancel out the x value where the hole is. And then from here, I'm left with a 1 on top and x plus 2 on the bottom. I can just, so when I plug in 3, I'll get 3 plus 2, 5. So this limit will be 1/5.